Then coming to the concept, Tesla coil, generation of high AC voltage by using Tesla coil. So he's one of the scientists, Nikola Tesla. This is so by using Tesla coil, is generated a very high amount of voltage. So not only in the range of kilovolts, million megavolts also generated by using Tesla coil. Several million volts can be generated by using Tesla coil. So he's one of the greatest scientists. Is explained how to generate very high voltages by using Tesla coil, and also he's trying to transmit the power without transmitting wires. Okay, but unfortunately, that experiment stopped because of financial problems. He's trying to transmit the power without transmission lines. Is one of the main concept. But okay, so what are maybe? So Tesla coil. So first, so these are the different types of learning objectives. So what is Tesla coil? First, the definition and a circuit diagram of Tesla coil, working principle of Tesla coil, and applications of Tesla coil, and then some related questions about Tesla coil. Try to consider definition. A Tesla coil is a radio frequency oscillator that drives the air core double-tuned resonant transformer to produce high voltages with low current. It's clear. So to produce high voltages with low current. So several millions of voltage can be generated by using Tesla coil. Okay, not only voltage. So very high frequencies can be possible to generate by using Tesla coil. Okay, very high frequency, that is called radio frequency. Okay, so by using resonant transformer, it's clear. By using resonance transformer, it is possible to generate very high voltages and also very high frequency. So that is the importance of Tesla coil. So one of the scientists, his name is Marconi, is developed a radio. Okay, so based on radio frequency only, the radio is working. Am I right or not? But actual concept of the actual principle of the radio is Tesla. Am I right or not? Based on a high frequency only, the radio is working. Am I right? That means the credit goes to Tesla only. But the radio is developed. The radio is developed Marconi by using Tesla coil, by using Tesla principle. Okay. So because of Tesla only, so nowadays transmitting the signal from one place to another place. Am I right? So the mobile phones are working on based on Tesla principle, high frequency signals. So to transmit the signals from one place to another place, we require radio frequency. The radio frequency can be developed by using Tesla coil only. Okay. So internet is also working on Tesla radio frequency, high frequency only. Because of that high frequency, there nowadays we are enjoying the internet. Am I right? So the different type of communications or devices are operating on. So this Tesla coil principle is clear. So here, first in this concept, first what we have to know what is meant by air core. Okay, you know well resonant transformer. It's not required to explain. So first, what is meant by air core, and so how we are getting very high voltages with low currents. Okay, that is the main concept of Tesla coil. So to understand better, let's define what is meant by radio frequency of oscillator. Okay. We are aware of that electronic oscillator is a device that produces electrical signal, either sine wave or square wave. You know well, electrical oscillator. Electronic oscillator is a device to produce the signals in the range of very high frequency. Without giving the input signal, it can be possible to generate very high frequencies. So, understood. You already studied in electronics, analog electronics, about oscillators. Okay. The electronic oscillator produces signals in the range of 20 kilohertz to 100 gigahertz. Am I right or not? By using oscillator, electronic oscillator is possible to generate very high frequencies. That is frequency is called radio frequency of oscillator. And generally, the radio frequency is nothing but in greater than 30 kilohertz is called radio frequency. 30 kilohertz to 300 gigahertz is called radio frequency. Okay, well, audio frequency just only 20 hertz to 20 kilohertz. Am I right? So first, considering Tesla coil working principle. So the coil has a ability to produce output voltage in several million volts based upon the size of the coil. If the size of the coil is very high, it's possible to generate very high voltages. Several million volts can be possible to generate by using Tesla coil. So that is the major advantage of this Tesla coil. Understood? The Tesla coil works on the principle of condition. It's called resonance. Resonance. Based on resonance, the Tesla coil is working. Okay, here the primary coil emits the huge amount of current into the secondary coil to drive the secondary circuit with maximum energy. Am I right? So by using spark gap, by using capacitor, it's possible to generate very high current to the primary circuit. By using spark gaps, it is possible to generate very high current. Okay, that primary current, primary current is passing to the primary winding of a resonance transformer. Then primary winding of the transformer is excited with very high current. Huge amount of current is excited by using spark gap and capacitors. It is possible to generate very high current by using spark gap and capacitor arrangement, LC and inductor. So by using primary winding, so we are by the primary winding is excited with huge amount of current. Because of that, the transformer is under resonance. Because of that, secondary winding is output voltage is very, very high, and also it is a very high frequency generated across the output side of the transformer, resonant transformer, that is called Tesla coil. Okay, the finely tuned circuit helps to shoot the current from primary to secondary circuit, tuned resonance circuit, resonant frequency. That is by using circuit, LC circuit, we can adjust the frequency. Can you easily understood when you are looking at circuit diagram? So high frequency AC voltage using Tesla coil. The circuit diagram of a Tesla coil. Okay, so here this is called a resonant transformer. Okay, this is also called as a Tesla coil. Okay, there's a primary side and secondary side is the L1 and is a primary coil. So this is acting as a LC circuit, tuned circuit, L1 C1, acting as a tuned circuit. This is called spark gap, this AC supply, and C2. That means primary and secondary windings are having its own capacitors, C1 and C2. So primary transformer, the resonance transformer. Okay, the primary winding having a capacitance C1 and secondary winding also having capacitor C2. Okay, so this is the Tesla coil equivalent circuit. So in this Tesla coil, the primary coil has two main parts: primary coil and a secondary coil, with each coil having its own capacitors like C1 and C2. Understand? A spark gap connects the coils and the capacitors. By using spark gaps, it's easy to connect the coil L1 and C1. By using spark gap, it is possible to connect L1 and C1. This is called tuned circuit, LC circuit. Okay. The functionality of the spark gap is to generate the spark to excite the system. This functionality of the spark gap is to generate the spark to excite the system. So to excite the primary winding of this transformer, this spark gap is used to. Okay. So Tesla coil working, this coil uses a specialized transformer. This coil is a specialized transformer. It's called a resonant transformer, or also radio frequency transformer. Okay, because of by using the Tesla coil, it's possible to generate very high frequency. That's why it is also called radio frequency transformer and an oscillation transformer. Okay, so this is the transformer. So these are the different types of same transformer. Can call as a resonant transformer, radio frequency transformer, and oscillation transformer. The primary coil is connected to the power source, and secondary coil is of a transformer is coupled to loosely to the ensure that it resonates. Primary coil is connected to the power source. Okay, through the capacitor C1 and one transformer, one high voltage transformer. So this is called one AC supply to we are using one of the transformer. Okay, and connected to the capacitor. Capacitor initially charged by this transformer only. Okay, a capacitor is connected in parallel with the transformer. Circuit acts as a tuning circuit or LC circuit to generate signals at a specific frequency. A capacitor is connected in parallel to this transformer L1. This capacitor is connected in parallel to this resonance transformer. Okay. The primary of the transformer, otherwise referred to as a resonant transformer, steps up to generate very high levels of voltage ranging between 2 kilovolts to 30 kilovolts, which in turn charges the capacitor. Okay, the primary side, so we are using one of the transformer, high voltage transformer. Okay, by using that, we have to charge the capacitor up to 2 kilovolts to 20 kilovolts. Understand? By using this transformer, by using the supply, so we have to charge by making some arrangement, by increasing the distance between these two, by proper distance between these two spheres, we have to charge the capacitor up to 2 kilovolts to 20 kilovolts, 30 kilovolts, 2 kilovolts to 30 kilovolts, which in turn charges the capacitor. It's clear. With the accumulation of massive amount of charge in the capacitor, eventually break down the air of the spark gap. Okay. After completing the charge of the capacitor, so what you have to do? After fully charged the capacitor, by turn off the supply, by turning off the supply. So the spark gap, so we have to decrease the distance between the spark gap. So because of that, air will become ionized and it gases. A spark is developed in between these two, and the huge amount of current is developed, and that huge amount of current passing through the primary winding of transformer. Because of that, huge amount of current, the primary winding of the resonant transformer is excited, very high current. Okay, and because of that, some secondary side is huge amount of voltage can be generated, and also with higher frequency. Okay. The capacitor emits huge amount of current through the Tesla coil L1, L2, which in turn generate high voltages at the output. Understood? Capacitor emits huge amount of current through the Tesla coil L1, L2, which in turn generate high voltage at the output terminal. Understood? So this is the circuit diagram. First, so again, try to concentrate by using figures. You can diagrams. You can easily understand. First, what you have to do, by using high voltage supply, by using high voltage transformer, we have to charge the capacitor. So like this manner, by arranging the spark gap, sphere gap distance, by arranging the sphere gap distances, some. Okay, acting as an open switch. Okay, during that, capacitor charges to very high voltages in the range of 2 kilovolts to 30 kilovolts. First, starting condition, we have to charge the capacitor up to 2 kilovolts to 30 kilovolts. So because of that, once capacitor is fully charged, the polarities are formed like this manner, plus minus. Understood? So capacitor is after fully charged. What we have to do? So we have to remove the supply. Okay. So we have to remove the supply, and then we have to decrease the distance between the spheres. Once it is decreased the distance between the spheres, means the air will be ionized and it acts as spark is up here. Okay. Once particular distance, it acting as a conductor. Then the capacitor is fully charged. Okay, then it will be discharging like this manner. Understood? So it will be discharging like this manner. So like this. The polarity of the capacitor here, plus minus. Current is always passing from high potential, low potential, high potential, low potential. Because of that, the capacitor discharges. Understood? Capacitor blocks AC, allows DC only. You know well. Capacitor store the energy in the form of electrostatic field. So if you are applying the AC, it charges to very high voltages. Okay. During charging condition, no current is passing through the primary value. Understood? So after completing the charging of the capacitor by making arrangement like this, okay. So the capacitor charges to the primary winding. So during transient, during starting condition, once the spark gap is spark is appear across this, okay, because of that huge amount of current is developed by the capacitor C1, and this current passing through the primary winding of the transformer, that is called L1. So that means the primary winding of this winding, this coil is excited with a huge amount of current. Because of that, secondary winding is also excited with, okay, because of this, these two are resonance condition. Because of then high voltage developed across the secondary winding. Understood? So like this, the transformer release the energy like this manner, and capacitor charges like this. So this is the principle of Tesla coil. So high frequency damped oscillatory output voltage. This is called high frequency damped output oscillatory waveform. Okay. So consider here, the high frequency, high voltage are required for rectifier DC power supplies and testing applications. Okay. And most commonly used high frequency resonant transformer is the Tesla coil, shown in equivalent circuit, and primary voltage 10 kilovolts only. But output voltage of the secondary side 500 kilovolts to 1000 kilovolts. This much of voltage can be possible to generate by using Tesla coil. But primary voltage is just 10 kilovolts, but secondary voltage is 1000 kilovolts. It is possible to generate by using Tesla coil. It's clear. A spark gap connected across the primary is triggered at the desired voltage, which induces the high self-excitation in the secondary winding. Understood? A spark gap connected across the primary is triggered at the desired voltage, which induces a high self-excitation in the secondary winding. Okay, because of that very high voltage generated at the secondary side of transformer. The primary and secondary windings are wound on the insulated former with no core, that is called air core, and are immersed in the oil. So tell me why you are using air core transformer? Why not iron core? So because of why using air core means the air never goes to saturation. Am I right? So the air can be handled very high frequencies. If you are increasing the frequency in the range of gigahertz, also it is possible to transmit the signal in the air. Because why? Because means air never goes to saturate. If you are using iron core in transformer, it's very difficult to handle that much of frequency because of saturation of the core. Okay, it's not possible to generate a very high voltage and also very high frequency if you are using iron core of the transformer. Okay, it cannot handle that much of frequencies. That is the problem we are facing if you are using as a iron core. That's why we can use it as a air core. Air used as a air core of the transformer. And then the transformer winding is tuned to a frequency of 10 to 100 kilohertz by means of capacitor C1 and C2. It's called circuit operation. And applications, high frequency, high voltage rectifier applications, testing of electrical apparatus for switching surges. Okay, advantages, absence of high core and saving in cost and size. We are using air core now. That's why absence of iron core, the cost of the Tesla coil is very less. Gradual voltage builds up and hence no damage to switching surges. Pure sine wave output, uniform distribution of voltage across the winding. Okay, so one small derivation is there about Tesla coil, oscillation frequency. So try to consider the combination of capacitor and primary winding L1 of the circuit form a tuned circuit, you know well. Okay, this tuned circuit ensures that both primary and secondary circuits are finely tuned to resonant at the same frequency. I mean, under resonant condition, the primary frequency and secondary frequency are same. Okay, the resonant frequency of the primary F1 and secondary circuit frequency F2 are given by F1 is equal 1 by 2 pi into root L1 C1. You know well, F2 is equal 1 by 2 pi into root L2 C2. As the secondary circuit cannot be adjusted, the movable tab L1 is used to tune the primary circuit till both circuits resonate at same frequency. Okay. Therefore, the frequency of the primary is the same as secondary. That is called F is equal to 1 by 2 pi into under root of L1 C1 is equal to 1 by 2 pi into under root of L2 C2. The primary frequency and the secondary frequency both are same. Okay, because of the transformer is under resonance condition. The condition for primary and secondary resonate at same frequency. Because of that, simplifying this expression, you will get L1 C1 is equal to L2 C2. It's clear? So 1 by 2 pi is cancelled, then L1 C1 is equal to L2 C2. You will get like this. The output voltage of the resonant transformer does not depend upon the number of turns ratio. You know well. Okay, it's not resonance transformer is not depending on the number of turns ratio as in ordinary transformer. As soon as the cycle begins, as per setups, the primary circuit energy stored in the primary circuit capacitor C1. Okay, and the voltage at which the spark breakdown is V1. The primary capacitor store the energy. Okay, so that is called W1 is equal to half CV square. Voltage energy across the capacitor. W1 is equal to half C1 V1 square. And similarly, energy across the secondary side, energy stored in capacitor across the secondary side, W2 is equal to half C2 V2 square. Okay, assume no losses. Ideal condition, if the no losses, the W2 is equal to W1, then V2 is equal to V1 into under root of C1 by C2 is equal to V1 into under root of L2 by L1. So you will get like this. In the above equation, this peak voltage can be achieved when air breaks down do not occur. So these are the different type of voltages. This voltage under air breakdown do not occur. The peak voltage is in the voltages at which the air breaks down and begins to conduct. Okay, next, advantages and disadvantages of Tesla coil. All of you try to consider. So allows uniform distribution of voltage throughout the winding coils. So these are one of the advantages. Builds up the voltage at slowly and hence no damage. The second one, and gate performance. And next, the use of three-phase rectifiers for higher power can offer tremendous load sharing. So these are the different types of advantages of Tesla coil. And next, disadvantage also there. Tesla coil possesses several health hazards due to high voltage radio frequency emission that includes skin burn, damage to the nervous system and heart. So why? Because radio frequency. Tesla coil possesses several health hazards due to the high voltage radio frequency emission that includes skin burn, damage to the nervous system and the heart. This is the one of the dangerous disadvantage of the Tesla coil, and it involves high cost in buying the large DC smoothing capacitors. Okay, capacitors are cost is very high, and construction of the circuit consumes much time as needs to be perfect to resonate. So to get the resonant condition is required more time. Applications of Tesla coil. At present, these coils do not require large complex circuit to produce high voltage. Nonetheless, a small Tesla coil find their applications in the range of sectors like aluminum welding. Okay, cars use these coils for the spark plug ignition. Okay, created Tesla coil fans are used to generate artificial lighting. Sounds like music. Tesla coils in entertainment and education industry are used to as a attraction at electronic fairs and science museums. High vacuum systems and arc lights. This is the application. And another vacuum system leak detectors. So these are the different types of applications of Tesla coil. Then coming to some questions about Tesla coil. So what is Tesla coil do? You know well. Tesla coil is a radio frequency oscillator that drives the resonant transformer to generate high voltage levels and low current. This is the important of Tesla coil. Can a Tesla coil charge a phone? Nowadays, smartphones are released with built-in wireless charging. So wireless charging, this is the one of the upcoming concept, wireless charging of phones. Okay, nowadays smartphones are released with built-in wireless charging, which uses the principle of Tesla coil. Okay, the wireless power transmission also our upcoming concept. Okay, in front of our So we are trying to focus on how to transmit the power by using without transmission lines. Okay. Tesla coil dangerous. It's very dangerous. This Tesla coil and its equipment are very dangerous as they produce very high voltages and currents which cannot be ensured by human body. And also one of the disadvantages, Tesla coil poses several health hazards due to the high voltage radio frequency emissions that include skin burn and damage to the nervous system and heart. So that is the very dangerous of Tesla coil. Why do Tesla coils make music? So also one of the question. Generally, these coils converts the air into the plasma that changes a volume and causes the waves to spread across the all directions, creating sound or music. This happens at high frequency of 20 to 100 kilohertz. Okay. How did Tesla transmit the electricity wirelessly? Okay, so these are our upcoming concept. So nowadays we are concentrating on how to transmit the power without using transmission lines. I'm already explaining this concept. A spark gap is used to connect a capacitor and two coils. As the power is fed to the transformer, it produces the necessary current and powers the entire circuit. So like this. So we have to transmit the power with like this. So that is all about the overview of the Tesla coil that can be used to generate electricity of high voltages, low current and high frequency. Okay. Tesla coil has the ability to transmit the electricity wirelessly up to several kilometers. Okay, so this is about Tesla coil operation. So voltage gain. So try to consider your primary winding energy in capacitor of CV scale. This is called secondary winding. Under no loss condition of CV scale, primary energy is equal to secondary energy. Then we will get V output by V in is equal to like this. Okay. So and also frequency, both frequency are same now. 1 by 2.2 root L C1 is equal to 1 by 2.2 root L. By using that, we will get like this, and we will get finally, so V output by V input. So gain, voltage gain. Okay, so this is about Tesla coil.